Hi, hello, namaste students. Welcome back to ASM Math tutorial. So today we're going to deal with one of the distributions of probability, that is binomial distribution. So it is one of the important distributions of probability. So to go for binomial distribution, so we should have some prerequisite. So what are those? The first important thing, we should know what is repeated trials or what are repeated trials. Okay, this is very important. Repeated trials means an experiment or a random experiment with only two possible outcomes, and that outcomes will be success, that outcomes will be treated as success and failure. Okay, that outcomes, whatever the outcomes from that random experiment, will treated as success and failure. So that is called Bernoulli trial. That is called Bernoulli trial. Okay, so any random experiment which contains or which produces only two possible outcomes, and that will be categorized as success and failure, and such an experiment or such a trial is called Bernoulli trial. Here the probability of success is always same for each trial. Okay, so now before going to binomial distribution, I'll just give the statement of Bernoulli's theorem. So what is Bernoulli's theorem? What is the statement of Bernoulli's theorem? We will learn. Proof is not required. I'm just giving the statement, then I'll move on to binomial distribution concept. So what does the statement says? Statement, okay, the probability of X successes, the probability of X successes in n trials is equal to NCX p power x q power n minus x. Here p, where p is the probability of success and q is the probability of failure. Say this is the very important prerequisite for binomial distribution, because if you know binomial theorem, then it is easy. Okay, what it says, binomial theorem, the probability of X successes in n trials, that is equal to NCX p power x into q power n minus x, where p is called, or p is representing the probability of success and q is probability of failure. Okay, so this will states the Bernoulli's theorem. Now based on this, we'll move on to binomial distribution. Okay, so what we're going to study in this particular session or video is binomial distribution definition, then the mean of binomial distribution, and the variance of binomial distribution. So I'll just go for the binomial distribution definition or statement, whatever you call. So what it says, if p is the probability of success and q is probability of failure, then probability of X successes out of n trials will be given by what? This NCX p power x q power n minus x. From this statement, we have to write what? the probability distribution table. Okay, so how to define binomial distribution? So we have to take, or we have to start with, if P is probability of successes, and Q is called probability of failure, then the probability of X successes out of n trials, is, we know, that is P of X equal to NCX P power X Q power n minus X. Okay, this is very important thing here, very important. So here P is called probability of success, Q is called probability of failure. So know why binomial distribution is used. What is the importance that we should know? When we have large number of trials, that time we are using binomial distribution concept. Okay, so that is the reason here it is mentioned probability of success and probability of failure, then the probability of X successes out of n trials. See, n trials are there. Okay, now from this we will write the distribution table. Okay, so the distribution table is always in the form of X comma P of X. So how we will write the probability distribution table? Let it be X and let it be P of X. X takes the values 0 to n because we have up to n trials here. Okay, so 0, 1, 2, 3, ... and the corresponding probabilities. What happens if I take X equal to 0 here? So what happens, it is NC0 P power 0 Q power n minus 0. So NC0 becomes what? 1. P power 0 is again 1. Q power n minus 0 means Q power n. So for X equal to 0, we have P of X as Q power n. When we take X equal to 1 in this binomial theorem or Bernoulli's theorem, what happens? NC1, because X is 1, I'll write NC1 P power 1 Q power n minus 1. So that is P into Q power n minus 1. In the same way, if we take X equal to 2 here, this becomes what? NC2 P square Q power n minus 2, because X value is 2 here. In the same way, if I write up to last nth term, it becomes NCn P power n Q power n minus n. N minus n 0. Q power 0 is what? 1. Anything power 0 is 1. NCn is 1. So we have P power n only because X takes the values of n. So it is P power n. So this is how we are constructing the distribution table from the Bernoulli theorem. Okay. Now, so we know the conditions for any distribution table. Now here what we will see, the value of P, what we have here. So this, for different values of X we have 0, 1, 2, 3, ... n. And these are the successive terms in the binomial expansion of P plus Q whole power n. So these are the successive terms in the binomial expansion of P plus Q whole power n. And this distribution is called binomial distribution, or it is also called Bernoulli distribution. Both are correct words. This is also called binomial distribution as well as Bernoulli's distribution or Bernoulli distribution. So what happens? As per the probability distribution, P of x is what? Always it should be what? 1, sum. So if I write all the values, what happens? It is q power n, nc1, p into q power n minus 1, nc2, p square q power n minus 2, dot 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 p power n. So it is nothing but expansion of p plus q whole power n. Okay. So this is equal to p plus q whole power n. So we know in the probability of success and probability of failure together, answer is what? 1. Therefore it is 1 power n. P plus q is 1, 1 power n is 1. Therefore 1 power n is 1. So hence we can conclude that P of x is probability function. So this is probability function. I hope you guys understood this. Very simple. I started with binomial distribution. So for binomial distribution we need repeated trials. What are repeated trials? That I already told. So the trial and a random experiment which are having outputs as success and failure, and that will be categorized Bernoulli's trial. Now Bernoulli's theorem we have. What is Bernoulli's theorem? The probability of x success in n trials is equal to ncx p power x q power n minus x, where p is the probability of success and q is the probability of failure. So once we know the Bernoulli theorem, we have binomial distribution. So how to define binomial distribution? If we consider probability of success and probability of failure of x successes out of n trials, then it is denoted by p of x equal to ncx p power x q power n minus x. So for this, if we write distribution, then it is of the form x comma p of x. So x p of x takes the values from 0 to n, and if I substitute 0, 1, 2, 3 x values in p of x, I'll get corresponding p of x values. So these are, and this is nothing but expansion, or these are nothing but terms of the binomial expansion of p plus q whole power n. Therefore summation of p of x, how we will write q power n plus this dot 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 p power n. Since it is binomial distribution, binomial expansion of p plus q, so p plus q whole power n equal to 1 power n. Why? Because p plus q is 1. So p of x is probability function. Now we'll find out the mean and standard deviation of the binomial distribution. Now we'll find out mean and standard deviation of the binomial distribution. So in probability we know the definition of mean. Okay, so what is mean? Mean is usually denoted by mu. So what is this mu? Summation n x equal to 0 to n x into p of x. So this is the definition of the mean. Now mu equal to summation x equal to 0 to n x as it is. We know p of x value. So what is p of x value? This is ncx p power x q power n minus x. Okay, so I just replaced p of x value, that is ncx p power x q power n minus x. Now I have to simplify, because this is, I need to find out mean of distribution, means I have to simplify this term. How to simplify this term? I'll write the given data, summation x equal to 0 to n x as it is. We know ncx formula. ncx formula, how we will write? N factorial divided by x factorial into n minus x factorial, because NCR, n factorial, n minus r factorial into r factorial. Using that we have written. This p power x q power n minus x will be retained as it is. Now summation x equal to 0 to n, this n factorial we can write it as how x into n factorial, I'll write it as n into n minus 1 factorial. Because I needed simplification, so that is the reason I have written this. N factorial can be written as n into n minus 1 factorial. In the same way, x factorial can be written as x into x minus 1 factorial, because we know the formula factorial, that is n factorial can be written as n into n minus 1 factorial, or it can be written as n into n minus 1 into n minus 2 factorial, like that. N factorial is nothing but n into n minus 1 factorial. In the denominator, x factorial can be written as x into x minus 1 factorial, and thus n minus x factorial I'll retain as it is. And one more thing I'll do here, what I'll do for this p term, p power x, I'll multiply and divided by p. Okay, so divided by p, and q into n or q power n minus x, I'll keep it as it is. Now what happens if we simplify this further? Just see here, this x cancel. Summation n equals to, x equals to 0 to n. We have cancelled x and x. So what we left with? N into n minus 1 factorial divided by x minus 1 factorial into n minus x factorial. Here I have divided and multiplied p term, so this denominator p goes to numerator. So what happens, it is p, numerator p will be as it is. When denominator comes to numerator, it is p power minus 1. P power minus 1, p power x, when bases are same, we can add the powers. So it becomes p power x minus 1 into q power n minus x. Okay, because p power x, p power minus 1 is p power x minus 1. So numerator p I have kept as it is. Now if I simplify it further, so what happens? Summation x equal to 0 to n. This n and p I'll take out from this summation. Okay, I'll just write n and p outside because both are free terms here. I'll write both n and p outside. If I write n and p outside, what are the terms we left with? N minus 1 whole factorial divided by x minus 1 factorial into n minus 1 minus x minus 1 whole factorial into p power x minus 1 and q power n minus 1 minus x minus 1. So how we have written this? Very interesting here. Please listen carefully. N and p are free terms. I have taken them outside. We left with n minus 1 whole factorial in the numerator, x minus 1 in the denominator. To write binomial expansion, or to write the standard form NCX like this, to write the given term in this form NCX p power x q power n minus x. Okay, I have to convert or I have to modify this term. So numerator n minus 1 factorial is there. This is of the form n. That is the reason n minus x factorial can be written as, I am adding and subtracting 1 here. This for this n minus x. So n minus 1 minus x minus 1 factorial. You can see here minus 1 minus into minus plus 1 cancel. It is n minus x only. N minus x factorial we have written. Why? Because I need to write in the standard form. Okay, that is the reason we have rewritten this n minus x factorial as n minus 1 minus of x minus 1 factorial. In the same way, this p power x minus 1 as it is, this q power n minus x also I have to convert into this form, n minus 1 x minus 1 form. That is the reason here also added and subtracted 1. So q power n minus 1 minus of x minus 1. Therefore, if I write mu equal to np, what we left with? Summation x equal to 1 to n, because if I take 1 here it becomes 0. Okay, so that is the reason we have started that summation from 1. If you take 1 minus 1 0, 1 minus 1 0 like that, so this series is not holds good for x equal to 0. Negative values we may get like that. So we started with x equal to 1 here. When we take x equal to 1, you just compare this n minus 1 factorial n minus 1 minus x minus 1 factorial p power x minus 1. This can be written as in the standard form. How? That is n minus 1 c x minus 1 p power x minus 1 q power n minus 1 minus of x minus 1. Okay, so now it is nothing but binomial expansion, p plus q form only. Okay, so mu equal to np p plus q whole power n minus 1. So mu equal to np, what is p plus q? 1 power n minus 1. So 1 power n minus 1 means what? So it becomes 1. Okay, it becomes 1. Therefore mu equal to np. So the mean of the binomial distribution, what we are getting here, np. So very simple, my dear students. The only tricky part is this conversion or expressing or adjusting the terms according to the requirement of the proof. So that is the reason you have to be careful in this part. So this is mean. Now we have to find out its variance. Okay. So now we'll find out variance of the binomial distribution. Variance is usually denoted by V. Variance of the binomial distribution. So we know the formula. What is the formula? X equal to 0 to n x square p of x minus mu square. This is the variance. We have alternate formula for variance also, but that is not needed because here we are proving variance as the binomial distribution. We are not solving any problem. So there is no numerical data. Since no numerical data, there is no need of modifying the variance formula. We'll directly take direct formula and we'll find out variance of the binomial distribution. So this is the variance of the binomial distribution. Call this equation as 1. See, mu already we got for binomial distribution. Mu is with what? So it is mean. Mean we already got, np. So what we are supposed to do now? We are supposed to find out only this particular part. Okay. So what I'll do now? So I'll consider that part. What is that? X equal to 0 to n x square into p of x. So what it says? Summation x equal to 0 to n x square is there, no? For x square I'll add and subtract 1. Okay, I'll add and subtract 1 because of the problem requirement or the proof requirement, because if I do this modification then only I can simplify it. So then what happens it is, if I simplify it further, x equal to 0 to n not 1. So because if I add 1 also, there is no use here. So what I'll do, I'll add and subtract x here. I'll add and subtract x here. So what I'll do here, next from x square and minus x, I'll take x common. So we left with what? X into x minus 1. Okay. Then what is the remaining term? Plus x into p of x. Now we operate this p of x inside. So summation x equal to 0 to n x into x minus 1 p of x plus summation x equal to 0 to n x into p of x. Again you see here, this is mean. This is mean of the distribution. So mean we already got it. So then again the problem is simplified. We have to simplify only this particular part. Only this particular part. I'll just rewrite one more step. Summation x equal to 0 to n, summation x equal to 0 to n, x into x minus 1, and this p of x, we know binomial theorem or Bernoulli's theorem, that is ncx p power x q power n minus x. This p of x I have written, plus this is mean, we already find out, that is np. So this x p of x under summation is nothing but np. Now we have to simplify this particular part. This is very, very important here. So first, x equal to 0, n x into x minus 1. This ncx, ncr formula, how we will write? N factorial divided by x factorial n minus x factorial and p power x q power n minus x plus np as it is, plus np as it is. Now summation x equal to 0 to n. So this is already simplified. We have to simplify this particular part. Okay, how to simplify that we have to take care properly. So this x into x minus 1 we have to eliminate. X into x minus 1, if I want to eliminate, this x factorial can be written as x into x minus 1 into x minus 2 factorial. Okay, so that is the reason this n factorial also I'll write. So x into x minus 1, I'll write it as it is, n factorial n into n minus 1 into n minus 2 factorial. Okay, n into n minus 1 into n minus 2 factorial divided by x factorial x into x minus 1 into x minus 2 factorial. So what we left with? N minus x factorial. So here p power x q power n minus x plus np as it is. Now you can see this and this will cancel. This and this will cancel. So this bracket is only for this term. np is free term here. So don't have confusion. This not multiplied with this. It is free term. So x into x minus 1 will cancel here. So what we left with? We left with summation x equal to 0 to n. Okay. So x into x minus 1 is cancelled. So we left with in the numerator n into n minus 1 n minus 2 factorial divided by x minus 2 factorial and n minus x factorial. So since the it is shifted to second term n minus 2, here we have only p power x. So what I'll do, I'll multiply and divided by p square for this term. Okay, p square I have multiplied divided by p square term. So when you do multiplication and division, so multiplication term will be as it is, p square. If I write p square denominator, the denominator comes to numerator, so it becomes p power minus 2. So p power minus 2, p power x, how we will write? P power x minus 2. When bases are same, we can add the powers. And that q power n minus x as it is plus np as it is. So simplification we have to do it carefully. Now we have to simplify further. So what are the common, not common, constant terms? Looks like constant terms or free terms. We will take them outside. Here p square is free term, n into n minus 1 is free term. So these terms I will write them outside. So it becomes n into n minus 1 into p square. So n into n minus 1 p square, if I write them outside, so if I take 0 I will get negative value, if I take 1 I will get negative value. I have to start this with only 2x value for 2. So therefore it is x equal to 2, x equal to 2 n. So what we left with in the numerator, n into n minus 1 if I take an outside, so it is n minus 2 factorial. We left with divided by, what is there? X minus 2 factorial. Since numerator is n minus 2 form, I'll split this denominator n minus x factorial is also that n minus 2 form only. Okay, So this becomes what? N minus 2 minus x minus 2 factorial. N minus 2 minus x minus 2 factorial, and this p square have written outside, we left with p power x minus 2. Also this q power n minus x also we have to write in the n minus 2 form. So q power n minus 2 minus x minus 2 plus that last term np. So this is equal to n into n minus 1 into p square, n into n minus 1 into p square, summation x equal to 2 to n. So it is of the form n minus 2 c x minus 2, because standard binomial expansion it is. So p power x minus 2 q power n minus 2 x minus 2 minus plus np. So this is nothing but n into n minus 1 into p square, and this is whole term is binomial expansion, that is p plus q whole power n minus 2 plus np, and you can simplify further, n into n minus 1 p square. This is p plus q means what? 1. Okay, so this will become 1 into something plus np we have, therefore if we simplify further, this is only what is this part, from this we have considered only this part, but in the variance we have this part also. Okay, so we'll rewrite this equation 1, means this I'll substitute and this I'll substitute at the end. So what I'll get variance v equals to n into n minus 1 p square plus np. This is summation of x square px minus mu square is there in equation 1, so that mu square is what? np whole square. So this if we simplify, okay, by taking n square, n term common, so we will have npq. So this is the variance of the binomial distribution, and we know standard deviation sigma is nothing but what? Square root of variance. Therefore standard deviation sigma equal to square root of npq. So dear students, this is all about the mean and standard deviation of the binomial distribution. So this is variance we have started with and we have done. Okay, so I hope you enjoyed this video. So in the next class we'll solve some problems on binomial distribution, then we'll move on to Poisson distribution concept. So for VTU students, the derivation is very important. Learn it properly. It is very simple, and not only VTU and other universities also, the derivation of mean and variance is very important. Also you should remember the mean of the binomial distribution, variance of the binomial distribution, as well as standard deviation of the binomial distribution. So thank you all. Once again, my humble request, if you are not subscribed yet, kindly subscribe my channel. Kindly encourage others also to subscribe my channel. Share this video. So in the next class we'll move on to the problems with binomial distribution. Also, if possible, we'll cover Poisson distribution. So thank you.